Hi, welcome to another Algebra 1 video. In this video we're looking at section 4.3, which is parallel lines. In this video we're only looking at part 1 of the two parts. Part 2 will be about perpendicular lines, which will be linked in the description. In this video we will learn about the general concept of parallel lines. We will learn how to identify parallel lines on a graph. And finally, we will also learn how to write equations of parallel lines when you're given another line. So what are parallel lines? Well, I think that the best representation of parallel lines is to look at a line graphically. So let's say that you had this green line that I've graphed, and it had a slope of m, which denotes the slope, and that m value was 2 for this line. And let's say that this line passed through a point marked in the red point 1, 2. Let's say that you plotted another green line, just like the previous one with the slope of 2. Are these lines equal to each other? Well, no, we can see that these two lines are away from each other. So if we were to make a graph over here right now, then we'd see that this line is to the left of this line, and this line is to the right of this line. But one key distinct feature that we see for this is that the slope of this line, given by m, is also equal to 2. Because you can see that as the change in x increases by some value on this line, it also increases by the same value on this line. And similarly, if you increase the y on this line, then it will also increase by the same amount of y on this line, which tells us that the slope is equal to 2 for both of these lines. Now previously I told you that these two lines are not equal to each other, even though they have the same slope of 2. Well, the reason behind that is that in the first line that I have over here, it passes through the point 1, 2. But in this case, this line could pass through another point, which could be 4, 2. So from this quick experiment, what we can infer is that both of these lines have the same slope or the gradient, which is m equals to 2. However, the difference between these two lines is that they pass through two different points. In the first line we had 1, 2, which was our point, and in the second line we have 4, 2. So we can finalize our understanding of parallel lines that you can have two different lines that have the same slope or gradient, which in this case was m equals to 2, but you will have different points. For example, in this case you have 1, 2 and 4, 2. So if you have another scenario, you may also have different points, but you will get the same slope of m. So now we understand the overall concept of how parallel lines work. Let's see if we can identify parallel lines from a graph. So here I have three different lines, which are all different from each other because they all pass through different points marked in red. None of these lines are equal to each other because we can see that the points are not in the same exact location, and we can also see that the slopes of these lines are different. However, there is one set of lines in this question which have the same slope, and we know that to identify a parallel line we have to have the same slope for the two lines. So based on the points, we can see that none of these lines are equal to each other. Now let's say that you name these lines A, B, and C. If you look at line A and line C, then you could infer that line A is parallel to line C because they appear to travel in the same direction even though they have different points. These lines will never intersect because they will keep going in the same direction till infinity. So in a mathematical statement, we can say that line A, represented by the letter A, is parallel to line C. And this mathematical statement with this symbol with the two bars is read as A parallel to C. Now let's look at the second example in which we're given lines A, B, and C. If we look at all of these lines, we can see that they all have different points from each other. So for example, line A could have a point over here, while line C could have a point over here. In fact, line B could have a point that's over here. So by looking at all the points, we can say that lines A, B, and C are not equal to each other. And that is because for the same x value that we have over here, they all have different y values, and B does not even have a y value for the x value that would reside on this imaginary axis. Now let's look at the slopes of lines A and B. We can see that the slope of line A is heading downwards in this direction, and the slope of B is upwards in this direction. So we can say that line A is not parallel to line B. Now let's compare line A to line C. So we said that line A has a slope which is heading in this direction downwards, while line C is heading in this direction with a slightly positive slope. So again, we can infer that just like lines A and B, line A is not parallel to line C. And we can also see that because line A intersects line C at this point over here. Now finally, to compare line B and C, we can see that line B is heading upwards, while line C is heading over here with a slightly positive slope. So we can again infer that line B is also not parallel to line C. So in the end, we can finally say that none of these lines are parallel to each other. And a quick way to answer this question would have been that all of these lines pass through one common point over here. And none of these lines would be parallel because if they were parallel, then they wouldn't have this point of intersection. So to finally define parallel lines, we can say that they will have no intersection because we learned that in this case, if they do have an intersection, then they're not considered parallel. Finally, let's take a look at writing equations of parallel lines when you're given another line. In the first question, we're given the equation of the line y equals to 2x minus 6. And we're asked to find another line which is parallel to this line y equals to 2x minus 6, which passes through the point of 8, 16. We know that these lines will not have the same point at the x value of 8 because when we plug in 8 into this equation, y will equal to 2 times 8, which is plugged into the x, minus 6. And then if we simplify this, we get y equals to 16 minus 6, and therefore y equals to 10. So we can see that for the previous equation, y equals to 2x minus 6, our point will be 8, 10 instead of 8, 16. But the question is asking us to find a line which is parallel to this line, but it passes through 8, 16. So we've already verified that these two lines will have different points at the same x value. But now to find the equation of the line that's parallel to y equals to 2x minus 6, we know that the m or the slope value will be the same. So if we look at this equation, we can see that it has a slope of 2, which is the coefficient of the x in this equation. So based on the line y equals to 2x minus 6, we can say that the parallel line of that line will be y equals to 2x plus b. However, we don't know what the y-intercept of this equation is, and we will have to find that out by plugging in 8, 16 into this equation to solve for b. So to find the value of b, we will have to plug in 16 for the y, because 16 is the y-coordinate of this point, and that 16 will equal to 2 times the x value, which is positive 8, plus the b, which we will find out. So we get that b is equal to 16 minus 2 times 8, and this simplifies to b equals 16 minus 16, which will give us b equaling to 0. So we can say that the line that's parallel to y equals to 2x minus 6 is in fact equal to y equals to 2x plus 0, which we can rewrite as y equals to 2x. So in a final statement, we can conclude that the line y equals to 2x minus 6 is parallel to the line y equals to 2x because they have the same slope of 2, regardless of them having different y-intercepts of -6 and 0. And this is it for section 4.3 part 1, which is parallel lines. The link to part 2 of this section will be linked in the description, which will be about perpendicular lines, which is the opposite of parallel lines. And leave a like if you found this video helpful, and subscribe for more videos in the future. And I'll see you in the next video. Thanks for watching.